tomorrow or Friday. We have faculty development 2 days, and then we come back next week, and then you're off for a week, and then we come back for 8 weeks straight. So, polynomial and rational inequalities. They're easier than they sound. For example, polynomial inequalities. Actually, for both of these, is we have to, the steps are these. Set the equation equal to 0. Solve for x. When you set it equal to 0 and solve for x, what does that find for you? What are those x values that you're finding? The intercepts. These are the x-intercepts. And the reason we set the equation equal to 0 is because since we're dealing with inequalities, now you only need to determine where the function is above or below the x-axis. That's all we're looking for. Our solution will be the interval that satisfies the inequality. So we're only looking for intervals. You're only referencing the x values, the x-axis values. So for example, here we got this. So for example, if we said our f of x is less than or equal to 0, and this is our graph of our function, what would be our solution? Remember, we only want, what part of the graph are we looking at only? What's that? No, that's one of those are the important points. Those are what we call critical values, because that's where we base our answers from. What's the function looking for? Anything below. So this one says below the x-axis. So the graph is below the x-axis here from -infinity to -4. Is it a bracket or parenthesis at -4? Well, here, because it says the function itself is less than or equal to 0. So at -4, it's a 0. So in other words, this means if it's an inclusive, you include the x-intercepts. Union, where else? Yeah, -1 to 5. because we only want the intervals where the graph is below the x-axis. So that's all we want to do in this section. Less than or equal to 0, right? This is this first part. This actually means my answer, I can pick either in here or it could be in here. Any of those sections, if I said, give me an X value where this is true, I could pick a number here or pick a number here. And that's why I mean, put union in there. Because, yeah, we can include the x-intercepts. So let's look at example 1 here. Example 1. Oh, and also, do y'all remember? Do y'all remember what a multiplicity was? What is it? The degree is a little bit different. The degree is the highest exponent of the leading term. After you factor your polynomial and you get your x plus, let's say 2, x minus 5, x plus 1. After you factor your answer, your polynomial, into smaller binomial terms, these are the multiplicities. The multiplicities are the exponents of the factored form. And this last one, since there's nothing there, it's a 1. Well, the degree is the summation of all the multiplicities. So it'd be 3 plus 2 plus 1. So in this case, it's a 6. And that we have to know because if the degree is even, then we know both ends point the same direction, either up or they both point down, depending on the leading terms. So the multiplicity is after we factor out our answer, we look at the exponents of the factored forms. So as the multiplicity of this first one is a 3, of the second one is a 2, and the third one is a 1. When the multiplicity is even, the graph bounces off the x-axis at that intercept. If it's an odd multiplicity, the graph crosses the x-axis at that point. So the multiplicity, so if we had this graph here, let me put that on another page. So we have x plus 2 minus 5 plus 1. I can roughly sketch what this graph's going to look like. What are my intercepts? So negative 2, 2, 3, 4, 5, and negative 1. We know the degree is what? I'll give you this page after I finish this side. You take a picture of it. Because yeah, we talked about this stuff here and how to find what we're looking for here in this section. So
The degree is fine.
no.
No. Did I see it again?
Uh,
Oh, you wrote it now.
well, it's just, if it, okay.
Oh, sorry.
There's more people here than just you. No, if you add up the degrees, remember there's a 1 there. It's 6. Since the degree is 6, both ends point up or down. What determines their direction? Look at the leading terms, leading the coefficients. They're all positive 1. So our A value is positive. So our graph at the end points both point up. Because it's positive. It's 1, but it's greater than 0. There are no negatives here, so there are no negatives anywhere. So what happens at negative 2? Since negative 2 is this one, it has an odd multiplicity. We know the graph crosses the x-axis at that point. At negative 1, at the negative 1 intercept, the multiplicity is 1. So it's odd, so it crosses that one also. And we have a y-intercept somewhere. I'll show you that in a second. And then when the graph comes down at the 5, it's an even, so it just bounces off that one. So the graph will look something like this. So for this example, what if I said I wanted f of x is greater than 0? In other words, I want this whole equation where it's greater than 0. So what part of the graph do I want? Above or below the x-axis? Above the x-axis. So let's look at where is the graph above the x-axis? Here, here, and here. So look at the x values at those points. What's the interval for this one?
Yeah.
Bracket or parenthesis? Parentheses, because it's not equal to. Unioned with the next set, which is from negative 1 to 5. Unioned with 5 to infinity. It's anywhere the graph is above the x-axis. So here's example 1. X plus 3, x minus 1 squared. It says solve this by graphing f of x, x plus 3, x minus 1 squared. It's kind of redundant because that's the only way we can solve it is by graphing it. So what are my x-intercepts? -3, you're right from that one, and +1.
That it?
We only have two factored forms. What's my degree? So if it's odd, what does the graph look like? Opposite directions, right? Either like that or like this. But since the coefficients are positive, it's an increasing function. We know our graph will look like this. Do we know the y-intercept? The answer should be yes. How do you find the y-intercept? Put 0 in for x. So if you put 0 in for x, we got 3 -1 squared. So at 3 is our y-intercept. I was going to show you in the earlier question, but I forgot. In the earlier question, the y-intercept was 200. Because 3 squared is 8. -5 squared is 25. And 1. So 25 times 8 is 200. So what happens? Now at -3, does the graph cross or bounce off the x-axis? Right, because the multiplicity is odd. Set x equal to 0 and work it out. Yeah, anywhere you see an x in the equation, set x equals 0. So you just have 3 and then -1 squared. At +1, do we cross or bounce? Has to be bounce, yeah, because we have to go back up. And it's also an even multiplicity. So what's our solution?
Oh. It's above the x-axis.
Yes.
So -3 to. No, -3 to 1, 1 to infinity.
Right. And they're parentheses because it's not equal to.
I wouldn't have this. Oh, above.
Because we cannot include this 0.
Oh, it's at 0.
I know you get there. Which is why we can't use -3 as a part of the solution. Okay, example 2. Solve the inequality. Solve that inequality. Give you all a couple of minutes to work on it. Let me put the steps here. Has to be equal to 0. The reason it has to be 0 because we're going one value that makes it equal to 0. If it's any other number, then you can have any combination of values. So the first thing we have to do is move the x over. Then factor it. They both have an x in common. Set each factor equal to 0 and solve for x. So x equals 0, x cubed minus 1 equals 0. So x equals 1 and x equals 0. Now what? Yeah. What's the y-intercept? Well, yeah, whenever x equals 0, y has to equal 0. And that's one of the factors. And then we have another one at 1. What's the degree of the equation? Yeah, the largest exponent is 4. So since it's an even, that means both ends point the same direction. The multiplicities are odd, or are they even? Because we're supposed to have degree 4. If we look at these, if it's 1 and 1, 1 and 1, that's only degree 2. We have to have degree 4. So both of these multiplicities are 2. Because we have to add them, we have to have degree 4. So where's our function greater than 0? It's here, here, and here. Negative infinity to 0, 0 to 1, 1 to infinity. Remember, look at the graph. And to determine your answer is look at the x values where that graph is satisfying those conditions. Okay, now let's move on to a little bit more difficult concept. Rational inequalities. meaning we have fractions. Same steps, has to be equal to 0, so your rational function has to be something equal to 0, less than, greater than, whatever it's going to be. And now here, remember when we graphed rational equations last section? Whenever you graph rational equations, what kind of points do you have? What kind of things do you look for? Okay, we need to find x-intercept. How do you do that?
No.
Set the numerator equal to 0. How do we find our y-intercept? Set x equal to 0. Solve for y. You were getting there.
Oh.
Well, you said those words. Not in that order, but you said those words. So to find the x-intercept, you only set the numerator equal to 0. Solve the numerator. To find the y-intercept, set the x's to 0, and whatever's left is your y-intercept. Okay, what else do we find? Asymptotes. We have horizontal, we have oblique, and we have the vertical. How do we find the vertical? Denominator equal to 0. And then you could either have one or the other. How do you find those? Degree of numerator and denominator. Not the coefficient. It's the x values that have degrees. Okay, once we find all those, what do we do? Yeah, figure out where it fits in the graph. And then we put our answers accordingly. Example 3. Your rational equation, we want it to be greater than or equal to 0. And r is equal to x minus 1, x squared minus 4. So go ahead and find those pieces of information. So basically what we're looking for is x minus 1 over x squared minus 4 is greater than equal to 0. So our x-intercept is where? 1. So the top equals 0, so x equals 1. Our y-intercept is just a constant. -1 over -4. 1/4. Do we have a horizontal or oblique asymptote? Horizontal, because the oblique asymptote is if the top is bigger than the bottom by 1, and it's not. So there's more on the bottom. So the horizontal asymptote is at y equals 0. And our vertical asymptote, set the bottom equal to 0, we get plus or minus 2.
How did you do the horizontal?
look at the leading terms. This one only has one, this one has two. So if we cancel the x's, there's more x's on the bottom. We got 1 over x. As x goes to infinity, this one goes to 0. All right, so we have our x-intercept at 1. Our y-intercept at 1/4. -2 and +2 are our vertical asymptotes. And so how do we figure out a graph? We know we have an intercept there and intercept there. And since the degrees are 1, that part has to get that. Because there's no other x-intercept there. Now, the only part we have to look at is which quadrant is it above or below the x-axis here? Let's look at a point. When x is -3, we have -3 minus 1, -3 squared minus 4. So 9 minus 4 is 5, -4/5. So this side will look like this. There's no other x-intercept. And at +3. 3 minus 1, 2/5. So it's positive. So that's that one. That's what we did last class as well. Now, we only want which part of the above or below the x-axis? Above, because it's greater than, and we can include the x-intercepts. So where's the graph above? From -2 to 1, union with 2 to infinity. So far, so good. So the hardest part is once you find the horizontal and vertical asymptotes, plot a couple points because you know it can't cross the x-axis anymore because there's no more x-intercepts. So if the graph is above, it'll be a type of exponential type of or the x-squared type function. Before we go any further, I made an error back here. This equation here can be factored out further. It's called the difference of two cubes. The difference of two cubes, you have one real solution and two imaginary solutions. So this, when we factor this out, we got x cubed minus 1 so this multiplicity is 1. This multiplicity is 1. This one's 2. That's where we get our 4 from. So why is that important? Because at 1 and 0, the graph crosses the x-axis. So that part is not included. And whatever happens underneath here, we have to plot points. So we have to remember a cubed minus b cubed is a minus b, a squared 2ab 2 plus b squared, a cubed plus b cubed, a plus b, a squared minus 2ab plus b squared. Again, because we had to have a degree 4, I forgot where that is. So our solution was not bouncing, it was crossing. Okay. Okay. Example 4. X, nope, wrong one. 3x squared plus 13x plus 9 x plus 2 squared is less than 3. Remember, your equation has to set equal to 0 first. What's the first thing you got to do? Make sure everybody's on the same page. Set it equal to 0. So the first thing we have to do is move that 3 over. Then what? LCD. So this one's got to be x minus or x plus 2 squared over x plus 2 squared. X squared plus 4x plus 4. X plus 2 squared is x plus 2 times x plus 2, which is this. Then we have to simplify the numerator. So x squared, negative 12x, negative 12. Three x squares cancel. 13 minus 12 is x. 9 minus 12 is negative 3. Looks a lot nicer now. We have to answer these. So what's the x-intercept? Just set the top equal to 0. So it's x minus 3 equals 0, x equals 3. What's the y-intercept? -3/4. Very good. Do we have an oblique or a horizontal asymptote? Hmm? What's the degree on top? What's the degree on the bottom? So it's a horizontal asymptote. There's more on the bottom, so it's x-axis. Vertical asymptote? So those are all the points I have. So what can you tell me is going to happen here? Well, let's plot some points. Because here's the horizontal asymptote. There's no x-intercepts here. So if its answer is negative, then we know it'll be like this. If it's positive, it'll be like this. But we'll show you another thing to look for in a second. Because the multiplicity is 2. It's an even. So let's look at this. At -3, we got -6/1 all the way down to -6. At, let's say, -4. So we have -7 over, no, the -3, it makes it 1. Yeah, so squared. So -4 makes it 2, makes it over 4. And we know this one here. What happens at 4? 4 minus 1 is 1, 6/36. Something like that. But because the denominator has an even exponent, even multiplicity, that means at this vertical asymptote, both sides approach the same value. We've seen these before. We've seen these before about the bouncing and the crossing of the x-axis and this one here. Let's first finish this solving this one, and I'll show you where we've seen it before in the library of functions. So we're looking for everything less than or equal to 0. The graph is less than 0 from -infinity to -2. And then from -2 to 3. So let's look at what we talk about. How the library of functions is pretty important. Remember we talked about if the multiplicity is even, it bounces off the x-axis. Well, what does the graph of x squared look like? Its multiplicity is 2. Its solution is 0. It just bounces off it. X cubed. It crosses through it. So if the multiplicity is odd, it'll cross. If it's even, it'll bounce. Likewise, with rational functions, the multiplicity of the vertical asymptotes, if it's an odd degree, what happens to the graph? They point different directions. So when you look at the denominator, if it's an odd multiplicity, we know that at that vertical asymptote, it'll go opposite directions. If the vertical asymptote has an even multiplicity, then both sides will approach infinity from both sides, the same infinity from both sides. All right, so once in other words, if you have a multiplicity and like our last one, we had what, x plus 2 squared on the bottom. So at -2, since this side was approaching it this side, I knew this side had to approach it also. Simply because of what we learned from the library of functions. And that's why I told you all many weeks ago, memorize those. It'll give you the leadway of so many of these functions. All right, what I plan to do is next week is I want to finish the chapter. We have one more section to do. And then on Wednesday, we'll just do nothing but homework problems off the computer. So make sure you're working that over the weekend. And then that way you have a whole bunch of questions and we can solve them all during the class next Wednesday. And if you had no questions, then you have to show up next Wednesday. That's all we're going to do on Wednesday. But Monday we'll finish up the section 6. All right. So no school tomorrow for you guys?